So let's start with the amino acid classification. Yes, amino acid classification. So in that amino acid classifications, we have three type of things based on the individual aspects. So first, let us see based on the nature of amino acid. Okay, first one is based on the nature. Nature of amino acid. We have acidic amino acid, basic amino acid, and third one, neutral amino acid. Okay. So based on the nature of amino acids, we have neutral amino acid, acidic amino acid, and basic amino acid. What do you mean by acidic amino acid? More number of COOH group. More number of COOH group. So yesterday I told more number of okay, sorry. I got a call. That's why. Fine. So acidic amino acid is based on the number of OH group that gives you an acidic amino acid. So usually one COOH group, that is carboxylic group, is present. Rather than that, okay, rather than that, how many carboxylic group are present? It refers the acidic amino acids. For example, we can say the examples are aspartic acid and glutamic acid. So you should remember at least these two because it's easy to remember that because acid is there in the last ones. Okay. So aspartic acid and glutamic acid. So it means sodium and basic amino acid. Basic amino acid means more number of amine group. means to say NH3 plus or NH2 plus group. So if the more number of NH2 plus group is present, that gives you the basic amino acid. So the basic amino acid, we have the example of lysine. Lysine. Okay. Lysine. Then what do you mean by neutral amino acid? The number of carboxylic and amine group should same. Okay, should same. Then it is called it as neutral amino acid. So we can give the example of glycine, alanine. Okay, glycine, alanine. So, and I told you in my last class only, glycine is the only one amino acid which doesn't having or it doesn't obey the chiral carbon atom rule. It doesn't obey the chiral carbon atom rule. Okay, so based on the nature of amino acid, we classified into three. There is acidic amino acid, basic amino acid, and neutral amino acid. So what do you mean by acidic amino acid? Acidic amino acid is a type of amino acid where we can see more number of carboxylic group is present. Example, aspartic acid, glutamic acid. In our basic amino acid, we have more number of amino group, that is lysine, and in neutral the number of carboxylic and amine should be same, and that will gives you as lysine and alanine. Okay, lysine and alanine. So next, let me move on to the second classification. So first one is based on your nature, second one is based on your structure. Okay, based on your structure. You should remember this: based on the nature, based on structure. Okay, based on structure, it classified into, okay, based on structure, it's classified into aliphatic and aromatic. In that aromatic, we can write, okay, aromatic. This aromatic can be further classified into heterocyclic amino acid. It can be further classified into homo and hetero. Okay, so aliphatic amino acid means the amino acid which is present in the linear structure, and aromatic amino acid is ring structure. We are specifically called as benzene ring. Okay, benzene ring. So what do you mean by homo and hetero aromatic or cyclic? Homocyclic and heterocyclic amino acid means homocyclic amino acid which having, or you can say which doesn't having a different group. Here it's of same group is called homo, and a different group is called hetero. What do you mean by same group and different group? I can write it and show you in the example. For example, we are writing this is an benzene ring. If this hydrogen is replaced by your nitrogen, this is called heterocyclic. Okay, heterocyclic. If it is all the corners is completed or filled with your carbon, this is homo. Okay, are you my point? Yes, Megan asking something. Ma'am, in basic amino acid, we have to find the number of ammonia. Yes, right, in our group only. Yes, yes, Meghana, you're right. Because in all the amino acids, your NH group or NH3, NH2 group remains, carboxyl group also remains same. So why you need to calculate it again? That's the first question. And she's continuing it. Ma'am, is every we have to calculate in our group only? No, ma'am. Yes, in every structure, in out of 20, 21 amino acids, you need to calculate only the R group because everything remains same. That's why. Shouldn't we include the other groups? Uh, you can include, but the number becomes same, right? Number will remain same, no problem. If it is changes means that changes should be occur in R group only. Okay, we're gonna got it. You can calculate. I'm saying If you calculate also, 1 should be same, no? 1 is always same. If it needs to change means that should be in the R group only. So that's why we are saying directly you can go with the R group and directly you can deal with it. Okay, fine. Is it fine? Okay. Then this is called homo and hetero. So we have an example for aliphatic amino acid, that is glycine, lysine, serine, cysteine, aspartic acid. Okay, this and all, whatever the linear change, you can give the example for this. And in homocyclic, okay, can you see here? Yes. For the homocyclic or aromocyclic, you can give the example of tyrosine, phenyl, phenylalanine. For heterocyclic, proline, tryptophan, and histidine. Okay, are you getting my point? So these are all the classifications based on the structure. But usually when you go with the Google or any books, they'll give you have 3 aromatic amino acids. Okay, you have 3 aromatic amino acid, that is tryptophan, tyrosine, and phenylalanine. They'll directly ask you like this: tryptophan, phenylalanine, and tyrosine. Okay. If you forgot this is homo or hetero, we just remember like the aromatic amino acids are 3 in number. It is tyrosine, tryptophan, and phenylalanine. You have only 3 aromatic amino acids. There is tyrosine, tryptophan, and phenylalanine. Okay. Okay. I'll move now. So then third one, based on the biological important. Based on the biological important. So based on the biological important, we have essential and non-essential. Okay, essential and non-essential. What do you mean essential? Essential means it is not synthesized in our body. It is not synthesized in our body. We need to take it through the diet. It is not present in our body, so we need to supply through our diet. Okay, that is called as essential. That is called as essential. Essential means we required, we want it. Okay, non-essential means it will synthesize in our body. Okay, it will synthesize in body, so no need to taken from the dietary sources. No need to take from the dietary sources. So then what are the essential amino acids? Essential amino acids are lysine, valine, leucine, isoleucine, phenylalanine, tyrosine, tryptophan, methionine, arginine, histidine. Okay, histidine. I'll repeat. You just write it down. Lysine, valine, leucine, isoleucine, phenylalanine, tyrosine, tryptophan. Sorry. It is not tyrosine. It is threonine. Tyrosine alla threonine. It's not tyrosine. It's an threonine. Threonine. Okay, threonine, tryptophan, methionine, arginine, histidine. These are all the essential amino acids. The non-essential amino acids are glycine, aspartic acid, serine, cysteine, tyrosine, proline. You have limited non-essential amino acids, that is glycine, aspartic acid, serine, cysteine, tyrosine, and proline. Okay, shall we move on? So we have three types of classifications of amino acid. One is based on the nature. We have acidic, basic, and neutral. Based on the structure, we have aliphatic, aromatic, and heterocyclic. And biological importance, it's a essential and non-essential. Okay, just give me a second. I'll take up the lines. Okay then. Okay, next we have properties of amino acid. Okay, properties of amino acids. So amino acids are an amphoteric in nature. Amphoteric means to say what? It having acid and basic both. So amino acid or call it as amphoteric compound. AMPHOTERIC, amphoteric in nature. Okay, amphoteric in nature. So why we are saying? Because having both acidic and basic group. So it having both acidic and basic group. So that's why we are call it as amphoteric in nature. Okay. So because of the presence of this acidic and basic group, this amino acid will exist the state of Zwitter ion. This is very important word. This is very important word. This is very important. Okay, Zwitter ion. So what do you mean by Zwitter ion? An compound or a molecule, no problem. Compound or a molecule which exist which exist in both plus and minus state is called zwitterion. ಅರ್ಥ ಆಗ್ಲಿಲ್ಲ ಅಲ್ವಾ? I'll explain. See, this is the structure of your amino acid, right? This is R group, and this is H. So what do you mean by zwitterion means? What do you mean by zwitterion means? This is the original state of your amino acid. Okay, it convert to this. Okay, can you see now? That's fine. So this is the basic nature of amino acid, and it will exist in this form, but it will convert to this. This is called zwitterion form. Zwitterion. What do you mean by zwitterion? In one molecule or one compound, you can see the charges of plus and minus in the opposite direction. Both are present at a time in one molecule is called as zwitterion. Both plus and minus are present in a single compound or single molecule is called as zwitterion. Okay, can you able to understand? This is very important question for 2 marks. What do you mean by zwitterion? All the amino acids out of 20-21 amino acid, all the amino acid will exist as zwitterion form. It will exist. Okay, fine. Shall we move? Next. Next property. Isoelectric point. Isoelectric point. So what is the isoelectric point? We know that iso means same. Electric point means it's a some point or a, we can say, fixed point. Fixed point. Okay. Some points, the point has to be same or fixed. Okay. So where it will fix? What do you mean by that? That is all we need to know now. So first I'll show you one example. Like this is one filter paper. Okay, we have one filter paper. So what we do, we just want to calculate the amino acid. We just want to calculate. We have one sample in our hand. Okay, we have like you will detect acid radical, right? So which acid radical is present in the given salt, like that. Same, we need to calculate the amino acid present. Okay. So first we'll take the filter paper, round filter paper, and we'll put a line like this, and I'll made a small circle inside. Okay, I'll made a small circle inside. And what I'll do, I'll just take an guessing point of the amino acid. For example, I have 4 tubes, that is A, B, C, D. I don't know D. Based on these 3, I need to calculate D. Which one the amino acid having in D. Okay, so what I'll do, I'll just take like this, and I'll point here A, B, C, and D. Sorry, D. Okay. So anyway, I have a tubes. So I'll just take the sample from the tube and I'll add here. Okay. By the capillary action, by the capillary tube, I'll drop the amino acids here. So when I put the solution in the mid, that is called solvent solution. When I dip this paper, this molecule will try to move towards your corner. Okay, it will try to move towards your corner. How will you know that it will move? Where the paper get wetted. Okay, when the paper get wet, you can say the amino acid is moving. You can say the amino acid is moving. So till where that amino acid will move means where the point which having the solubility factor. For example, 1 glass of water having the capacity of dissolving 5 spoons of sugar. Okay, so at the same kind, this amino acid is moving. Okay, at some point this paper will allow that amino acid to absorb in the surface. For example, how much it required the solvent, that much it give, so it will stick over here, it doesn't move further. So this is the point. For B, maybe here. For C, maybe here. And D, it's showing here. So based on this, okay, it's finished. Then we need to spray the what to say, indicator. Okay, we need to spray the indicator. Indicator will give the changing in the color, right? Whenever the pH changes, the or to say your indicator will give the color. So same like that, based on the length from here to here, we just compare the D with all three and we'll give this D may be equal to your A. Just see, almost in the same zone, right? So by this method, we'll calculate the unknown amino acid by comparing with the known amino acids. So now, what do you mean by isoelectric point? Isoelectric point is a point where the pH of an amino acid, the pH of amino acid solution, pH of amino acid solution at which amino acid does not move either towards anode or towards cathode. It means to say, if suppose this is your anode and this is your cathode, it will stick on here. It doesn't move towards your outside. It doesn't move towards your inside. It will stick on the one surface. That point is called it as isoelectric point. Okay, that point is called it as isoelectric point. So I can show, anyway you know that electrode and all system. So based on that, I'm trying to explain in that way. So this is our electrolysis method. So we have this. Okay, fine. So what I did, I just connected this. I'll take it as a cathode, and this is your anode. Okay, this is your cathode and this is your anode. So what I'll do, I'll just take the solution. Okay, I'll just take the solution. This solution contain sodium. Okay, this contain chloride. Okay, this contain chloride. So what happened here, the chloride is surrounding with your sodium ions. Just think like that. Okay, with your surrounding. So what happened, because of the passing of current, your ions will stuck on it, and because of the same ions, here also sodium, here also sodium, because of that it doesn't attract, it doesn't repel, it will stay at the same position. It can't move towards your anode, it can't move towards your cathode. Are you getting my point? ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? You can try with one more example, like you just hold two magnet of the opposite side. Okay, of the opposite side. So it will repel, it doesn't allow you to attach to that, and it doesn't allow you to move further. Are you getting my point? So it doesn't have the capacity to move towards your anode, or it doesn't have the capacity to move towards your cathode. It will stick on the one position, where that position will give you the much more solubility. Will give you the much more solubility. Okay, are you getting my point? Can you able to understand? What do you mean by isoelectric point? This is 1 mark question. This is 1 mark question. Can you able to understand? Gokul, Sujan, speak out. Meghna. So where the amino acid? So by seeing this example, you can understand. I think so. It will dissolve here because of the favorable condition. Yes, I favorable condition. Because of the favorable condition, it will stick here. It doesn't move towards outside or move towards inside. So you can say the definition like this: the pH of the amino acid will suit to the solution and it doesn't move towards your anode or towards your cathode. Okay, fine, then good. ಬೇಗ ಅರ್ಥ ಮಾಡ್ಕೊಂಬಿಟ್ಟಿದ್ದೀರಾ. So next, let us see the isoelectric point of some of amino acids. Amino acid isoelectric point. I'll write the table now. This is amino acid and this is isoelectric point. Here glycine 6.0, alanine 6.1, serine 5.7, cysteine 5.0, aspartic acid 3.0, 9.7, tyrosine